All right, a lot of people were late today. Thought they were going to be the rest of you rock up. There was just a little minor question about the dot product from 5F. Have I gone past it already? No. So from 5F, still not there. Really? Right, this one, sorry, why is that meaningless? And as some people recognised, is similar to some of the questions we did last year. Not similar, the exact question last year. But basically, this is making you realise that when you do A dot B, you get a scalar, so just a number, and then it doesn't make sense to do the dot product of a number with another vector. You actually have to have a vector and a vector. Okay, and then this last one, that is making sure that you remember your properties. So this should be forming part of your notes page, getting familiar with it. This dot, it's just normal expansion as you would normally do, nothing spectacular. I think for that last one it was difference of two squares, so the middle terms would disappear and you're left with A dot A, which is actually the length of A squared. So it's just using those properties, simplifying, make sure that we're all good. Yeah? It was then asking you to look at the dot product. And I think we've got that under control. Is that all right? And what do we remember about the dot product? It is a scalar as well, but what's the big whoopsie-do with it? When it equals 0, the two vectors are perpendicular. Huzzah! And then we can find that to work out the angle between them. Now, again, your calculator can do that. So as we're going through these, could you make sure that you can do it by hand and by technology? Yes? All right. Look, trust me with all of this stuff. We repeat, but with the applications in Chapter 6. So you guys have had a pretty good grounding from Year 11, and you don't have to remember too much, but this is all... We will do some of this possibly in your investigation. Well, imagine, here's your room. You're going to have a room in your investigation. You've got some, mosquitoes and their directions. But the thing that we want to do today is, they do it in a little bit of a weird manner. So, just before we hit Chapter 6, remind me, did we look at the cross product? Yeah, I think we did. So, got the cross product, which I think we called just working out the determinant of 3 equations. We did it with linear equations, and so you should be familiar with this process. Remember seeing this a little bit? Right? So, if I want to find the cross product of these two vectors, we start with this ijk, which ends up being like 1. And then we pop, so B cross C. I said these two, but it's actually B and C, sorry. So 1, 2, 3, 2, 0, 4. And then we remember, what does that, how do we actually work that out? Good, diagonal. So 2 times 4 minus 0 times 3. And then it's 1. So 8 take 0, that's how we get the 8. 1 take 4. I don't do it that way. Do you remember what I did? So we'll just do this very briefly, and the little face I just saw then, it's because your calculator will do this. All right? So, and you've been away, don't worry about it. We'll lob quite easily. So maybe a little bit of a heading, cross product. And this repeats itself where we use the cross product in Chapter 6. So we're dipping a little bit, and then we'll repeat it. So we'll have a heading cross. Oh, didn't realise that was going to be orange. So absolutely we should remember it from the determinant last year. But we'll just work through this one together. So if we want the cross product of B cross C, Okay, B, so it's going to be 1, 2, 3. If you've got your textbook open to page 134, because then you can just see slight difference to what I do. And I think I made you guys do it, so. Or maybe I gave you a choice. Basically, when we have this, because we've got I, right, we rule out that one and we rule out that one, so we're just focusing on the 2, 3, 0, 4. Okay, and that's what I will then write, over there. So we're going to go 2, 3, 0, 4. Now this is where I differ from the book. I say plus J because I then wrap around. I go from here and then I go around that way. So I take the 3 and the 4 and the 1 and the 2. Now the book says minus J and it does 1, 2, 3, 4. So it will do 1, 2 and 3, 4. You'll get the same answer. I just like to have everything plus, because when I have the minus there, sometimes I forget it and I make a mushtaq. So it's up to you. If you would like to play along and do what the book does, I will not be offended. Just make sure that you don't stuff up. And then K, you've got your last, again, you rule out that, and you've got 1, 2, 2, 0. Correct? And what we're then doing is we're saying 2 times 4, and you don't have to write this line down unless you really forgot everything. 0 times 3 plus J, and that will be 3 times 2, minus 4 plus K, 1 times 0 minus 2 times 2. And so that's how we get 8, 6, take 4. Thank you. Minus 4. And away we go. Yeah? Same answer. What you're going to realise when we do chapter 6, what does this represent? Well, when we have our 2 vectors, we've got vector B, we've got vector C. This vector here that we have, it is perpendicular to both vectors B and C, right? The cross product of 2 vectors will give us the vector that's perpendicular. And why will we need that? We will need that later on to find the equation of the planes. So we're going to find equations of lines in 3D and equations of planes. So at the moment in chapter 5, they will just remind you about this. We'll get more practice in chapter 6. That's a typical example. So if you think I've gone really quickly through 5, fear not. We get to rehash everything again. All right? So keep that on the back burner. It's just so if you thought, some of you I know were going through all of chapter 5 and yeah, it wasn't necessary. So don't be alarmed if I now go, let's leave 5 and we're going to start off with our applications of vectors. Are we happy with that? Excellent. Sorry, it was just also as you're going along with this, have your calculators out and remember how we can do some of this stuff. So look, I don't use it all that much, but we go options and I'll just exit for a minute. So you either look at math, that's one of your handy ones because you've got vectors in there, and you've got options. So we have to go option. We go F2 for matrices, nothing there, nothing to see, nothing to see. Oh, hello, something to see. Cross product. So you press that, but you have to now put your 2 vectors in. I'll do that again. Right, so just go exit, exit, exit. Back to normal mode. We go option. We want matrices / vectors. And then we just keep pressing the arrows. You go across and nice things start to appear. So we go cross product, but we now have to put the vectors in. And if anybody finds a better way to do this, by all means, let me know, right? I then press exit twice, so go back to the maths. And now I have to put my vector in. So it's a 3 by 1. What was it? 1, 2, 3. Oh, wasn't that nice for me to remember? 1, 2, 3. Arrow across, put the comma.
The next one's 204.
Oh, you're so sweet. Close your bracket. And there she blows. You got a dimension error. You didn't put the comma? So the other one that you might have noticed when you're in normal run mode is you've got this. Now, I rarely use that. That is where you can store matrices or vectors if you're going to use them repeatedly. And I think general maths use that more often when you've got a matrix that is bigger than like 7 by 7 or m by, because, you know, we can enter a matrix quite easily here, right? If you've got more options here and you can go more bigger dimensions, but if you try that with, I think, a 7 by 7 or 8 by 8, it'll start going, no, I don't think so. So you have to go in and store it and then it's happy. So we probably will not really use that much. Okay, thank you. Sorry, because sometimes they're a bit long. But, okay, this one, if you've got a summary page, absolutely pop this on it. I have said before that when we've got our revision guides, or even before you get yours, I've got a photocopy that I can give to you of all the stuff that we have there. I'll probably find one and pass it around in a minute. But if you notice, what we just looked at was we can use the cross product of two vectors to find the area of a triangle. So formula, it's just this standalone little, we can use it, area of triangles, and then if that's a half, don't look down there, but how do you think we can find the area of a parallelogram, which might be two triangles? No half, that's right. Crazy town, but there you go. So two little formulas, and it is now giving you practice on how to use your cross product. And we're going to do a couple, just a couple, by hand, and then you're going to do it with your calculator, all right? It's also really nice because it's going to make you remind yourself, how do we get vectors between 2 points? Okay? Same thing too, we want to go from 1 point out. So little thing here, we don't do AB, we want the angle at A. Find the area of the triangle ABC, so they've used A, so it's AB and AC from the same point going out, not AB and CA. Does that make sense? All right. Oops. So we're not going to do all of those. Shall we do? Okay. 1C. Sorry, I have no heat because my aircon is fritzed. Oops. Right, yes, by hand and by technology. So you could have done BABC or CACB, but inward, out. Those are the questions we're doing. We're up to question 3. How do we find D? So what can you tell me about the fact that it's a parallelogram? Chaps, shush. You've done this question. Oh, good boy. Carry on.
AD is equal to BC.
Right. We've got AD has to equal Oops. BC. Is there anything else that you could say? AD is BC, but also AB is equal to DC. So it's up to you, whichever one you wanted to go with, right? Ethan has started with AD and BC. So the first thing I'm going to do is find BC. So what is BC? Minus 1, take 2, minus 3, minus 2, 1. Have you noticed with all of these, if you actually accidentally do a whoopsie, like I'm really tempted then to go 5 take 4 is minus 1 instead of 1. So be on your ball, be on your game, otherwise you stuff up. Now I don't know what D is, so I've just called it XYZ. So we've got, let's put D, I want to put D right here, XYZ. So A to D, that means I've got X take 1, so X plus 1 has to equal minus 3. So therefore, X would have to be minus 4. A to D, B to C, correct. Capiche? When we did two-dimensional stuff, and we had equation of a line, what two things did we need to find the equation of a line in 2D? Slope and a point was needed. Well, now we're going to be looking at equations of lines in 3D. What two things do you think we'd need? Instead of slope, direction. And how do we get direction? Rhymes with pector. Right, because the vector has magnitude and direction. So the vector is going to give me the direction, and then we still will need a point. Right, so for lines in 3Ds, we need what we call the direction vector, which is just the vector, and a point. You don't have to write this down really, you'll see in a minute. The big thing though to notice with equations of lines in 3D is that there's actually 3 different ways that we can write it. Okay, so in 2D we had equation of the general form and we had y-intercept form, correct? And then I'm sure I probably made up some other forms as we went along. With lines, when it says 2 and 3D, you could write them like this in 2D, but we never did. It just didn't make sense, and so we're actually going to skip the first couple of questions anyway. But yes, we want a point and a direction, and these are our 3. Yes? Yes? Oh, please, if you're choking, always just leave the room. That was Dan choking. We will let you know if he survives. So we've got written as a vector equation, as a parametric equation, or as a Cartesian equation. You think, oh, hell's bells, really nice, really simple, but just don't mix them up. So let's have a look. When it's a vector equation, well, you're using the vector pretty simply. So here's our point, and here's our vector, 4, 5, minus 6, just written slightly differently. Do we agree? Right, so we're using our position vector for our point, so 1, minus 2, 3, so your point, plus a constant times your direction vector. Why? Because it can just keep on going and going. Yeah? So pretty straightforward. And we just have to make sure that whatever that constant is, it can't be 0. All right? In your investigation, whatever, some of the questions there, applications, things are moving, and they're moving after a certain amount of time. So quite often you'll have that as t for time. But anyway, parametric equation. You can see from here it's just 1 plus 4 times that. Most of the time, as we said, that would be a t. 1 plus 4t. You wouldn't have written this if you're not going to write all 3. So how do we get that from our original information? It's just the point value plus 4 lots of t. And then it will be minus 2 plus 5t and so on. Nice? And you can read your, well, they're using lambda. You could use S, you can use T, you can use R. All different variables you'll see now as we go through. But again, how do we find this? Well, on the top, we take away the points. So X take 1, Y take 2, Z just take 3. And you divide it by the vector component. Capiche? So it's just getting used to, can we find the equation of the line in 3D space? So we're not doing any of the 2D stuff. It's just ridiculous. How do they make it a little bit harder? Well, oh my goodness, they don't give you the direction vector. How rude. But if it passes through these 2 points, then of course we can find AB and BA. It does mean that you can have slightly different equations. And that's a bit of a pain for me, but that's all right. You can suss. All right? Suss. And you can see here, because they've done it 2 different ones, if you're using point A, they've got lambda as a thing, or you could have used S, and then if you use point T, you use a different variable. Okay? So, do we think we can do this quite nicely? We are not doing question 1, 2, or 3. We are kicking off from question 4. This is a long-winded exercise, but it's nice to actually, this is the time where we will stop skipping stuff and we'll actually do nicely. Things like, did I skip one? Come back here, we'll do that later. A line parallel to the x-axis which passes through the point -2, 2, 1. So if it's parallel to the x-axis, do we remember what that vector would be? 1, 0. Okay, because it's not, remember our axes here. Here's our z-axis, here's our y-axis, here's our x-axis. It's parallel to your x-plane, so we're not moving anywhere else. It's just coming out that way. Sweet? So you might come up with a few. If you get stuck, we can go through that in class on Tuesday, or you can just flick me something. What about xy, perpendicular to xy plane? Perpendicular to xy. So where is our xy? That's here. So it's perpendicular to xy. It's actually z. 0, 0, 1. Got it? So very simple, finding the equation, getting used to those 3 different forms, but then some of them are going to be a little bit tricky on how you actually get your direction vector. It's not going to go. Here it is on a silver plate. What are you guys doing at the moment? You okay? Yeah. No, I meant like with all your other subjects. Oh, you've got a test coming up, haven't you? All right, I was going to say let's chuck in the parallel and perpendicular, but because I'm so nice, let's see how much of 6b you can get done, and I'm really only starting from question 4. So, oh, I feel like I should give you more. 4 to 10. And yes, okay, see if you can do, this is like the angle between, we've done stuff like that before. So B and C. C is not very long. Yep, B and C.